Hi there. So we will be continuing on our problem solving. We are solving AQA GCSE Physics Foundation tier, the paper one. So in the last video, we looked at instructions and we solved some of the questions. And we will just be continuing from where we stopped. So we stopped here where we talked about the resistance of the particular coin, and we'll move to the next question. So the next question says the temperature inside the vending machine. Now, what is the story behind this machine? Let's quickly track back a bit. So here, this is the story. Figure 4. It shows a student putting a coin into a vending machine that sells food. We've talked about the frequency. Don't forget the mains electricity supply in the UK, that's 50 hertz. We also talked about the potential difference, that's 230 volts. And we did our calculation. We already have a formula here which says resistance equals potential difference in current divided by the current. So you could just go back to the previous video and see how we did all that there. So today we would be talking about the following question. It says the temperature inside the vending machine is monitored using an electrical circuit. Figure 5 shows part of a circuit. So this is an electric circuit. We have a resistor here. We have a thermistor. We have a voltmeter, and we have two cells connected to this entire circuit. So where's our question? The question says the circuit symbol for the thermistor is wrong. What is the circuit symbol for a thermistor? So this is not the actual symbol for a thermistor. So based on what we learned in class, what is the actual symbol? Now this symbol here is for a filament lamp, like a light bulb. This is the electrical symbol for it. What about this? This is for a switch. So maybe like you want to turn it on, turn it off. This is how it looks like in an electrical diagram. Now this one is the one for a thermistor. So this is our guy here. This is our answer for the thermistor. Now for the next one says, how could the potential difference across the resistor be calculated? So we have four different options. We have the potential difference across the battery. So the PD here technically means potential difference. So is that the potential difference across the battery minus the potential difference across the thermistor, the potential difference across the battery plus the potential difference across the thermistor. And then we have a multiplication here or division here. Now let's quickly go back. Now, something I must understand is something that we must understand here is that when we talk about the circuit, now how does it work? This is how it works. This battery here, that's the two cells here, they are supposed to power this device and this device, right? So it means that some part of this battery would go to some energy from this battery would go to the thermistor here, and we would have the remaining part going to the resistor. So what does that mean? So it means if I already know what the entire battery is, let me see if I could quickly write something. So let's take out this. So we have a battery, something like this. Then we have a resistor, something like this. We have our thermistor that is connected to voltmeter here. And this guy is 200 ohms. So now we already know this guy is 30 volts. Now, we see this guy supplies energy to this guy and to this guy, and it also supplies energy to this guy. But here we already know what the value of the total energy is, so we could say total, which is 3.0 volts. Now, if we know the value of energy inside the thermistor, let's just give it some letter. Let's just say T. So that means we could say T plus the value of energy this resistor is getting would give us 3. So what does that mean? 3 minus T would give us the value of energy from the battery inside the resistor. So what are we trying to say technically? That means if I'm going to get the value of energy or voltage inside this resistor, I just have to take the entire value and subtract the value of the voltage in the thermistor from the entire value, and that's how I'll get my answer. So how do we find that out in the question? So now we have these options. These it says the potential difference across the battery, that's the total potential difference. That's the 3 volts minus the potential difference across the thermistor. So that's our guy. So this is our answer. The next question says, at one temperature, the thermistor is in figure 5 has a resistance of 200 ohms. What is the potential difference across the thermistor at this temperature? Okay, now we are asked to calculate the potential difference across the thermistor. Okay, now because you see the potential difference across the thermistor, because the thermistor is going to take the same resistance of the resistor. And if these two guys are going to share this battery, and if they have the same resistance, because they have the same resistance, so it's practically like they're going to take it equally. So because this guy is 200, because this guy is 200, and this guy is also going to take the same 200 ohms resistance. And because they just have 3 volts to share, so at this point, they're going to share it equally. So this guy is going to take a 1.5, and this guy is also going to take a 1.5. So 1.5 volts would be our answer. Let's go look for 1.5 here. So that's here. This is our answer. And what's the reason at this point? So the reason is because the thermistor shares the same resistance as the resistor. It's as simple as that. Now in figure 6, we have a graph and a graph of resistance against temperature. And we are asked the question. It says, when the temperature of the thermistor is 10 degrees Celsius, the resistance of the thermistor is 600. Calculate the change in resistance when the temperature increases from 10 to 15 degrees Celsius. So this is how we do it. You just have to trace. This is the part of the temperature. This is the part of the resistance. So we just have to trace the value of the temperature to the curve, and then we trace it to the resistance. So this is what I'm saying here. For instance, at 10 degrees Celsius, we just have to follow this line all the way up. Okay, this is where it touches the curve. So we just take it to the resistance. That's 600 ohms. So what does this mean? So it means that at 10 degrees Celsius, we have 600 ohms of resistance. So now at 15 degrees Celsius, if we trace it up here, trace it to the curve, trace it here again, you have 200 ohms. So that's like, what will be the change? That's a 600 minus a 200. So technically, a 600 minus a 200 should give us a 400. Let me just rub this off. Okay. So a 600 minus a 200 would probably give us a 400. So a 400 is the answer we have been searching for. So what's the change in resistance? The change in resistance is the 400 ohms. So now, what are we supposed to work out here? So basically, we say from the graph, trying to erase this. So from the graph, at 10 degrees Celsius, we have 600 ohms. At 15 degrees Celsius, we have 200 ohms. So if we have this, trying to elongate the board, so change will be equal to 600 minus 200, which is 400. That makes sense. So let's go back to a question. So the next says, question 3. In a ride at the theme park, a person is strapped into a pod that is attached to two stretched bungee cords. The bungee cords behave like springs. Figure 7 shows a person using a ride. So there's a tower and this is like the spring. So you just have to stretch it forward, and this is the pod. And so you're inside the pod, and when you are stretched backward, and when it's released, you launched forward. That's a cool thing, right? But this is where we are going to. How is the extension of each Bongi chord calculated? So basically, if we are going to know the extension, now this is something that we learned under Hooke's law, where we talk about force extension, force constants, and all of that. And from there, we know that when we want to calculate extension, so what is extension? What does it really mean? Let me try to paint a scenario here. So extension actually is like the extended length, okay? And this is how it's going to make sense. And so if this was a rope, right? So this is the extension. So this is after so it was stretched to this point. So it's in broken lines because that's like the extension. So how are we going to calculate the extension? Now from here to here is, let's say, is the original length. Let's say the original length was 5 meters, for instance. And after it was stretched to 7 meters. So now you actually calculate the extension. So what do you need to do? You just have to do, okay, now what's the new length after it was stretched? 7 meters. What's the original length? That's 5 meters. So by the time you subtract the original length from the new length, that gives you 2 meters. So that tells you the value of this extension is 2 meters. So the same thing is what we will do is the same thing is what we will do in this question, which says, um, how is the extension of each bungee cord calculated? So the stretched length, that's the new length, minus the original length. That's how it's calculated. Okay, now another question says, before the pod is released, the extension of each bungee cord is 7.5 meters. Spring constant of bungee cord 800 Newton per meter. Calculate the elastic potential energy stored in each stretched bungee cord. Now they already gave us the equation to use. It said 0.5 times the spring constant times the extension square. So that is, so you just have to punch this in your calculator. So that's a 0.5. So I'm just also going to punch it in my calculator. 0.5. So what's our extension? So that the spring constant is 800 times 7.5. So I'm going to do that in my calculator times, okay, times 800 times 7.5 squared. So I'm just going to quickly press that in my calculator times 7.5 times 7.5. So this gives me 22,500 joules. So it's as simple as that, 22,500 joules. Okay, now we're actually calculating another question. It says the maximum speed of the pod is 15 meters per second. The mass of the pod is 240 kilograms. Calculate the maximum kinetic energy of the pod. Okay, it's all right. So they've given us the equation again. Great. Kinetic energy is equal to 0.5 times the mass times the speed squared. So what's 0.5 times the mass? That's 240 kilograms times the speed, which is 15 meter per second. So I just have to do the same thing in my calculator. 0.5 times 240 times 15 times 15. Okay, and should write that out. Just have to quickly run off the board, you know. So that's 0.5 times 240 times 15 times 15. And times 15 by 15, this gives us 27,000 joules. So answer is 27,000 joules. So now here we're asked a question. It said use the physics equation sheet to answer question 3.4 and 3.5. So yes, in this kind of exams, you're usually given an equation sheet where you have all the important equations that you will be needing in the examination. But here now we're asked a question, which equation links gravitational field strength, gravitational potential energy, height, and mass? If you think about it, well, the answer actually is this. That's the gravitational potential energy, which is equal to the mass times the gravitational field strength times the height. And that's what we learned in energy and energy stores. Now, another question says, the pod has 24,000 joules of gravitational potential energy when it is at maximum height. The mass of the pod is 240. Gravitational field strength is 9.8 Newton per kilograms. Calculate the maximum height reached by the pod. So here we already have the energy, we have the mass, we have the gravitational field strength. But now we're asked to calculate the height. So how exactly do we go about that? So let's quickly do that here. So we say EP is equal to N times G times H. And we're about to, this is what we want to find. We know this is 24,000, which is equal to 240 times 9.8 times H. So H basically is equal to 240, not 240, 24,000 divided by 240 times 9.8. So we have to first find out what is 240 times 9.8. So 240 times 9.8, you just have to check that in the calculator, is 2352. So you have 24,000 divided by 2352. 24,000 divided by 2352, and that's equal to 102.0 meters. So a height is a height of 102.0 meters. So our answer here is 102.0 meters. So we'll stop here. I would continue in the next video. Thank you.